Hey guys, welcome. Yeah, so another practice problem on the binomial theorem, right here at the top left, or the binomial expansion formula. Those are the two names for this guy here. I already made a video proving it, and I already gave you basic examples that were fun. So here's another example. And this time, the question that we have to answer is this, which is write down and simplify the term independent of x and the expansion of this here. Now, for this particular problem, it would be a bit more useful if we write this binomial theorem or binomial expansion formula with a plus b instead of x plus y. But yeah, keep in mind that if I wrote a plus b here instead of x plus y, all that would change on the right hand side is this x would be a and this y would be b. All right. So let's pretend like that's the case, which is we have a plus b instead of x plus y. Then looking at this here, we can see it in this form, in the a plus b to the n form. If we write this as x cubed plus negative 3 over x, and then all that to the 12th power. So then what I'm saying is the role of a would be played by x cubed, and then the role of b would be played by negative 3 over x, right? And so then since we want the term independent of x, we want to have a and b and this part multiply so that the x in the numerator from a and then the x in the denominator from b cancel each other out. So we have to pick r carefully. N is already decided for us. N is 12. We have to pick r carefully so that the n minus r power times 3 will equal the r power. And that's going to be a choice that looks like this, which is choosing r to be 9. Because when we choose r to be 9, the term involving 12 choose 9 will be 12 choose 9, and then a, which is x cubed, to the n minus r power, 12 minus 9, right? And then b, which is negative 3 over x, to the 9th power. That way, 12 minus 9 here is 3, so we have x cubed to the 3rd, which is going to be x to the 9th, and then here we'll have a denominator x to the 9th, so the x's will cancel, and this will be the term independent of x. Yeah, there are a total of 13 terms in the expansion of this guy, right? And this is the one term that will not have an x in it. Because both a and b have x's, all the other terms will have x's in them, right? And this is the one which fortunately will have an x in the numerator and x in the denominator with the same power, so they cancel. So let's simplify this a little bit more. 12 choose 9 means 12 factorial divided by 9 factorial times 12 minus 9 factorial. And then x cubed to the power 12 minus 9 is x cubed to the 3rd, which is x to the 9th right here. And then we can use exponent rules to write this in this form, right? Okay, cool. And then now look, we have an x to the 9th here, which technically is in the numerator. And then we have an x to the 9th here in the denominator. They cancel. So this term will be independent of x. All right, and of course there's more canceling that we could do to simplify it completely because it tells us to simplify, right? Okay, so first 12 minus 9 is 3, so this here is 3 factorial. So this whole thing is 12 factorial divided by 9 factorial times 3 factorial. And then we've canceled this x to the 9th with that x to the 9th. So here in the denominator of this guy, I just have a 1. Otherwise, I have this guy, right? Okay, now 12 factorial means 12 times 11 times 10 times 9 factorial. And we have a 9 factorial in the denominator. So it'll suit us to write 12 factorial in this fashion. And then 3 factorial here is 6. And the 12 in the numerator has a 6 in it, right? Specifically, this 12 is 2 times 6, right? Okay. And then I took the negative 3 to the 9th. And knowing that that will be a negative number, I put the negative in front here and just wrote a positive 3 to the 9th. All right. And then canceling the 9 factorial with the 9 factorial on the top and bottom. And then canceling the 3 factorial and the 12 into a 2, replacing the 12, we'll have this. And then multiplying the numbers in front of 3 to the 9th, that's negative 220 times 3 to the 9th, our final answer. Yeah? All right, cool. I hope you enjoyed this. And next will be expert examples. Two very fun examples in the expert examples video. All right, keep watching and take care.